One, two, three. Welcome back, guys. So today we're going to continue our topic from here. We are still going to continue subchapter 6.2, the rate of reaction. In a previous meeting, we've discussed on part 1 the concept of the collision theory. Okay. On it, we have known that we are going to have collision and energy. Those are the two things that must happen before reactant can turn into a product, or we call them for reaction to happen. Okay. Now, we're going to go deeper today on the concept of the energy. In the previous meeting, we've discussed that what is important is that for the kinetic energy to be larger, actually equal is okay, than the activation energy. Now, why do they need kinetic energy? Kinetic energy, when they collide, it's going to transform into the chemical energy that's used to break bonds. If the old bonds is not broken yet, then reactants cannot make new bonds and transform into the product. That's the importance. Okay, now, we've discussed yesterday that how to increase the kinetic energy. We can increase kinetic energy or decrease it. This is based on the temperature. Well, in fact, kinetic energy is nowadays being a temperature is being defined as average kinetic energy of particles. So we define temperature based on the kinetic energy level. How about the activation energy? Activation energy is the minimum energy required for a reaction to happen. Now, we cannot increase the activation energy. We cannot make reactions to happen harder, but we can decrease it. Okay, this happens if we have a help of a catalyst. Okay, so we are going to discuss today here about what a catalyst is and how it works. So let's start with the concept of catalyst. What is a catalyst? Catalyst is a substance, okay, that is going to increase rate of reaction. To do that, they need to be involved in the reaction. But in the end, they're going to be unchanged, okay, at the end of reaction. One of my favorite analogy of this is like a matchmaker. Okay. Without matchmaker, two people may make new bonds, but the presence of matchmakers is going to make things happening faster. Of course, to do that, the matchmaker must be involved with two parties. We're going to see later on A-levels the practical examples on how catalysts work. But for now on, you just need to know that there is such things that is going to involve in a reaction, make them faster, but they're not going to change at the end. And how do we explain the catalyst in the terms of reaction pathway diagram? Okay, suppose that we are going to have an exothermic reaction. We have discussed that what we call the activation energy is the difference between the location of the reactant to the maximum. This is called activation energy. It's always positive. Now, what catalysts do is they are going to make the bump here smaller. Okay, it's going to make them something like this. There. Okay. Because now the EA with the catalyst is now smaller, it is easier for particles to pass through the transition condition, and hence reaction happens faster. That is about the role of catalyst. So how the catalysts work? Okay. They're going to increase rate of reaction by decreasing the activation energy. That's it for today. Thank you.